So this is the improved pulse width modulating circuit that I'm using to control my oven. I don't. The oven will be plugged up here, which goes to a solid state switch that can do 120 volts. I have an oscillator here going into an inverter, and that's going into an emitter follower, which is driving a high-pass filter. A high-pass filter is to generate a pulse that goes into an inverter. That inverter goes and triggers the 555 timer, and the 555 timer generates the pulse width modulation. So right now the top is the clock and the bottom is my out. Oh, I should show that part. So the output of the 555 timer is then fed through one inverter, then fed through another inverter, but this right here is also a level shifter. So this is the inverter and that's the emitter follower, so this is a total inverter right here. Put a couple extra gates here to drive the load a little bit. The level shifter goes from, it has a 5 volt input and goes to 12 volts. I'm using a 12 volt supply and I'm doing the logic with 5 volts, so this is a voltage regulator with 5 volt output, and that's the bypass cap right next to it. So so the output wave on the top is my clock. The output wave on the bottom is my resulting pulse width, so I can go from nothing to about 10%, and I can keep increasing it. Oh, sorry, I got a wire in the way. I can keep increasing it all the way to about 90%, which is cool. So you see that right there? So anyways, this is my improved pulse width modulation controller for my oven. The other cool thing is the oscillator I use is actually 2 inverters. The circuit I used it's just this guy right here, and I put a pull-up resistor here to get the oscillator started. The waveform of the output of the oscillator is the top one, and the waveform of the other inverter is this guy right here. So, which is working. You'll notice that I don't, my PMOS and NMOS or the pull up and pull down is not equal strength on the devices I'm using, so I'm not getting 50% duty cycle, but that's okay because I'm looking for a pulse. So anyways, the output is fed into the low pass filter, which I was talking about earlier. This is not the result of the low pass. This is the result after the low pass is fed through an inverter. Sorry, let me zoom in. And the inverter basically generates so the pulse basically generated a 100 microsecond pull down trigger. So the 555 timer is triggered on a falling edge right here. So basically I get a really quick pulse, and then what that allows me to do is, by having a really quick pulse that doesn't affect the width of my modulated output. So if I had a pulse that was this wide, the minimum modulated output I could do is up to here. So I needed to do a really quick pulse. And so anyways, that's my pulse width modulator that I'm going to use for my oven, because the cheap part, which I actually have over here it is, this part, which is worth about 3 cents US, but I cannot buy anywhere, broke, and I'm replacing it with this guy, which is pulse width modulation output. My previous version, the previous version I was doing self-triggering from the 555 timer, and the output was not very steady. So I have some jitter here, but it's very little. As you can see, it's very smooth. So previously, as I changed the duty cycle, it would change the frequency as well. So right now I'm running at a little over 47 hertz. I think that should be slow enough for my switch. My switch has a 8 microsecond switch time.